Good evening, ladies and gentlemen, and welcome to a new stream. Feels like it's been ages, but it hasn't been that long. Let's see, music goes down. We're doing a long pre-stream today, but I'm already tinkering with stuff to get it ready. Who's all here tonight? Let's see, we have Nigel Young. Let's see if we get smoked tonight or not. And then Kavala is here, and Philip is surprised by the early music. Will it be good tonight? No, it's not officially started yet. No, I know, we're in the pre-stream. Let's go, says Justin Webb. Smoke now. You demand it. The smoke is demanded. I don't know about that. We'll see. But I first need to prepare my load testers. So let's do that in the pre-stream a little bit. Yeah. So how is everyone doing tonight? Oh, this one's too big. Safety glasses close by. Yes, and the thermal camera. I think I finally got it working. Not exactly the way I want it, but close enough so we can enjoy the thermal camera real time on stream. Ooh. Tonight we're drinking, or we're going to drink some Lipton Iced Teas Zero Sparkling. I like that one. It's good. So let's prepare 3 testers, I think. Is that enough? Maybe we need 4 testers. I don't know. We'll see. No can. What happened to the real Quindor? Yeah, what happened to him, huh? I don't know. Let's see. See if we can get this working. It's always a bit of a hassle. And no ultra, right? What is going on? What is going on? So let's see, it needs to go in there. And then this one is the most important. Screwing for days. See, these never go in right. That's the problem. I need bigger forks. I don't know, this doesn't feel right. Let me open that up a little bit. Close it over here. Standing in line. No. We have the Albert Heijn. They come by once a week. And they take your old bottles and cans with you. With them. So, no standing in line. See, I never like this. It's too short. Is the other side longer? Oh, it might actually be. So let's give that a try. Statiegeld, yes. Let's try this side. Well, pushes it out. I never liked this. I need to come up with a better way to do this. You still don't have that? What? What do you mean? You don't have statiegeld in Belgium? Nope. It's a mess. Only on certain glass bottles. Oh, okay. So what I might end up doing is actually, let me give that a try with these cables. Although these are dual ferruled, right? We might actually put a ferrule on the dual fork crimps and then I think we can get a tighter fit. So let's give it a try over here. So we need one of these jumpers, that's no problem. Okay, so the jumper is secure over there. And then can we add this guy? We used to be able to take our plastic bottles to the Netherlands to get money for them, but they changed the bottles and it doesn't work anymore. Aw. Okay, let's see. Let's see, this is a much better fit. Okay, I think I'll do that. So we will, I'm going to leave these cables as they are. This one too. But I think we're going to modify our dual fork crimps to be one fork crimp and one ferrule. Well, let's see. Let's give that a shot. Oh wow, okay. Almost can't cut them. I probably just need to get my enormous scissors. Much better. Okay. See, this one got all squished now. Okay, and then it seems it fits the blue wire or the blue ferrules. Let's see. I don't think so. Maybe we can fit the 4mm ones. Let's see. Have you had your Skycam installed at your building site? No. We're still well away from that. First, we need to configure the VPN and then test all of that, and then test with some IP cameras locally, and then they kind of need to start the build, or at least we need the bouwstroom. I could borrow that from a neighbor, I guess. So it's still a little bit out. So we get to play with it more first. I was afraid of that. These ferrules don't fit. They're not big enough. We'll have to dive into our ferrule kit. Or, well, not the kit. This is the kit, I guess. One moment. Is it this one? No, this is fuses. It's this one. So we have lots of various ferrules here. It's not SV2. Maybe something in this bag. Maybe. Let's see. Oh, these are all fork grips. Okay. And these are also not long enough, are they? I don't think so. Yeah, more ferrules. Maybe these are big enough. Let's give it a shot. Oh, interesting. Guest icicles. Oh. The dog wrecked them. It's almost big enough. Just not quite. No. Okay, so this was 40009. Not sure what that means. This is 12. Okay, so maybe that's 12 gauge? I don't know. Let's give that a try. On the black wire, yes. Yes, that will fit. And then we still need to get them into the terminal, so we'll have to see. Okay. It's not long enough. I need to strip it more. Okay. So, but I want more of these 12s. Do we have red ones too? Maybe. Oh. You'd think so. If I have black ones, I should have red ones. Maybe they're in here. Yes. I even have even bigger ones. Those are... I don't know what those are. Okay. Let's get that out of the way. And this out of the way. This needs to go. Okay. So I need to strip it a little bit more. I guess I could also go in with the exposed wire. That is true. I just like my ferrules. But these terminals do allow for that. That is true. I messed it up. So we're still in the pre-stream. So what are you guys drinking? Right? Because I'm drinking my boring iced tea. Yes, look at that. Nicely poking through. Perfect. Okay. Let's crimp it and then see. Now we have a choice. We can do a box crimp or a four-sided crimp, or we can do a hexagon crimp. Coke Zero. Oh. Beer and crushing Aliexpress. Bad combination. 50 meters of LED strip. Nice. Coffee. I'm gonna try the square crimp. See if how that works. Okay, so there. Okay, yeah, it's nice and square. It's pretty good. Okay, so now let's see how well that works with this terminal. It's 4:10 p.m. here. Okay. I need to open it up a little bit more. There. Let's see. In theory that fits. In practice, not sure. Because, I mean, it's a square hole. Right? So you'd think you'd be able to get that in there. Maybe it's just too big. Maybe I just crimp it a bit more. No, I think I just want to use 2 large diameter wires, but you know, let's try it without the extra wire. You'd think this would fit. It goes to the square hole. Oh, I know. I remember. I know that's short. Yeah, I think so too, Greg. But still can't get this one in. Let's try the hexagon crimper. Now it's like over crimped, but you know. Well, it didn't do much. Probably not enough crimping force. No, so maybe I just get new wires, because this is, what is this, 12 gauge? 10 gauge, okay. So probably if I got some 12 gauge, which I have nearby, I can just make new wires, because I've been annoyed by these wires every time we use them, basically. So let's see. Where is the 12 gauge? I know it's in here somewhere. Hold on. I think it's just quicker to make new wires, and then this problem will be solved. Nope. I knew it was in here, but now I'm not 100% sure. Okay, maybe I put it somewhere else. It doesn't matter. I found this giant bundle of 12 gauge. Okay. And then we probably also don't need these. 10 gauge. How many amps? Well, we're going to do load testing. And today we're going to do that at both 5 volt and some other volts. So let's see for this one. Where's my scissors? So let's separate these. Should be okay. Oh, I have those here. I think these will fit the gray ones. Yes. Perfect. A little bit more stripping. Don't forget the hammer. Oh, come on. You guys didn't come to watch the 2-hour-long crimping stream. Now we're going to do this quickly. Yes, nicely poking out of the top there. Perfect. Okay, we're going to try the square crimper first. See if we like that. So, I'm not sure about this square crimper. It's not exactly square. But I believe it does fit this terminal just fine now. Look at that. Easy. Right? Perfect. Okay, so we're going to use 12 gauge. Plenty of that. Let's see how long we want the wires. Let's make them one desk length. Or just about. So then we have plenty of room to maneuver all the things. Like that. Okay, so I'm gonna make a few. Yeah, I already ordered a new square crimper because I don't like this square crimper because the crimps come out anything but square. And then I'll see. How many are we going to make? We'll make 3 to start. Okay. Hello, hey Spandex. Carefully cut into the insulation, because otherwise it tears. There. Oh, let's get this out of the way. We already set the stripper. Oh wait, I shouldn't strip them the same on both sides. Oh well. Okay. So we're gonna do quick crimping action. Yeah, I was gonna do a poll to see if we want to do that one first or the 5-volt power supplies. So do we want to do the... Yeah, it's kind of squarish. I don't know. I mean, it tried to make it square. Ish. Yeah, do we want to do the PD trigger to 24 volt, however that works? I think there's a boost converter in there. It has to be. Or do we want to do the 5-volt supplies first? Save the weirdest. Yes, okay. Well, that would be the YouTuber thing to do. Oh, good. I didn't strip this one. Good. Oh, good. I didn't strip this side either. So I only have one that I double stripped already, but we can fix that. Okay, so now we have 3 wires where we have this side done. Good. So now we need to do the other side, and that needs 4 clips. Whoa. Because those will likely go on power supplies. Let's see, this needs to go into this baggie. Oh no! SV25, that's not the one I need. Okay, I need to clean that up at some point. 5.55, yes, I think I need those. 2.4. 5.5, okay. You didn't miss much there, Thomas. What is actually the weirdest thing you ever tested or used? On stream or not? Because, I don't know, maybe competitor LED controllers? Those have some weird stuff in there. Right, so we need this crimper. And we need the stripper, but then we strip much less. Yeah, something like that. Okay. Let's see if this will fit. This should. Yeah, that's good. And I never really pay attention to what slot of these you should use. So I just use the tightest one. Oh. there. Oh, it's stuck in there. Okay, let's do another one just for good measure. Okay, well, it's kind of crushed, but it's on there. That's the most important part. Okay, maybe I should use the middle one. Let's try the middle one. Let's see. Well, that might actually be better. Let's give it a one more. There. Yep, that's good. Okay, one done. So these are stripped way too far. Let's see if they leave the insulation or not. I think I can. Oh, I think I can make that work. Crimp Fest. Yeah, I can make that work. Okay. There. You can also see that it's a nice crimp. It's stuck in my crimper now. Okay. There. Okay, second cable done. Need to strip this. Let's use another method where we put the crimp in first. We hold it tight. And then we insert the wire. Yeah, that's actually easier. How many secrets are we telling you tonight? Oh, I don't know. I haven't really prepared a secret. I was in China last week, so been busy with that. Oh, wait. There. Oh, now would be a good time for an ad. At least YouTube thinks so. Ah. Okay. There. Third cable done. So let's clean this up a bit. I actually accidentally cut one of the cables before, and now there's all kinds of sprinkles on my disc. I do not know if it will short circuit things. We'll see. Okay, good. Nope, this one still needs to go there. Okay. So let's build one tester with the new cables. We need to make sure this little loop wire goes in, and then our normal wire does. Let's tighten it down there. Whoa, noise. Okay, this one goes here. Then we need our little loop wire. Let's tighten it down on this side first. And then over here. Yeah, nice and tight. I probably re-crimped these by tightening them. And now we have a good size wire. Nice. Okay. So let's do a quick poll. What we want to see first. Poll. USB-C thingy. Five volt. Start poll. Let's go. Now I'm going to do something which has become kind of common on the stream recently. I'm going to vacuum my desk. So be prepared. I'll mute it. Let me mute the microphone. Okay, with a freshly vacuumed desk, which still shows sprinkly parts, let's see where the poll ended. End poll. USB-C thingy, 58%. 5 volt supplies, 42%. Okay, so we're going to test these guys first. And well, that's going to be interesting. So we have two, so we can blow up two. Or, I don't know, and then open them up. Right? Okay, it comes with a USB-C plug and a barrel plug on the other side. Now, barrel plugs are annoying, so we're just going to snip that off. I don't like barrel plugs. Bye-bye. No need for it. We're going to do more wiring work. Okay, let's strip that back a little bit. There. Oh, they got a nice red and black wire inside. That's nice. Okay. Those are really thin wires. I guess it looks like copper. That's good. I don't know if it's copper though, but we'll see. Let's see if my smallest crimps will fit on those wires. Because it's... Damn. Hmm. Yeah, I don't know about that. Let's see. Yeah? Okay. That's good. There. Perfect. So now at least the barrel plug or converter or whatever isn't going to be the problem. Let's get one of these testers and wire it up directly to the tester. And see when it explodes. I really think this thing is going to melt, explode, something. Yeah, I can't imagine this thing surviving. We'll see, we'll see. I will definitely have the thermal camera on there and my glasses. Well, not on there, but on. So this is a 2 or 4 wire measurement. So the middle terminals actually measure the voltage, so you could run extra wires, so you're not measuring the voltage drop in your wire, but the actual voltage that whatever is supplying the voltage is delivering. I generally don't find that too important for these tests, so I don't use that in these tests, but in other tests it can be important, right? Because you're then actually measuring the voltage of your supply instead of the drop on your cable. Take it out of the box. No, we're first, we have two. So we're first going to test it, just like this is. Let's see. Let's try to use the one without the cable. Or we could also use this e-sagger that I unpacked. What can it deliver? USB-C 20 volt 3.35 amps. That should be plenty. Let's do that. Then maybe the cameras won't fail. Oh wait, no, it can't be. Oh wait. Oh no. This thing is very short. How do I keep it on the screen? We might need an extension cable and then this adapter. That can work. Do I have an extension cable here? No. Hold on. Okay, we have an extension cable. Okay, there, here. Let's put on the safety glasses. Okay. Let's plug this in. There. Let's get a 12 volt cable for the tester. Okay, we need to have this on screen. Little bit zoom out. Yes. Yeah. Okay. Ah, that works. That works. Now I can't reach the button, so that's good. Not good. Okay. So let's hook up the thermal camera, and I tested this before the stream. In theory, this will work. Let me first. So I've been trying to do this in basically what you'd call infrastructure mode. This hasn't worked for a year, but I just tried the AP mode, and that seems to work. So although this has the function to connect to your Wi-Fi network, as you can see here, that doesn't work. So you can go to AP mode, enable that, and I have a wireless dongle in my PC now. So we're going to connect to that and hope the stream doesn't cancel. We'll see. Maybe I don't have a network connection anymore. It's still connecting. So let's launch the tool. Okay. Oh, you can already see the tool a little bit. Let's see. Video, connect, confirm. Now I hope this works. Yeah, let's hope so, Matthew. We still have the streams. Oh, yeah, okay. We can see something. Okay, well, that's a bit small. There. Okay, yeah. Oh, we can see all the buttons. Let's focus on the buttons. So now we can real time see what the camera's seeing. That's pretty good. But for some reason I have to do this in AP mode, and it doesn't work in connected to my own wireless network mode. What I bought the damn thing for. But anyway. Okay, let's turn on the tester. There. Oh, I guess we can also see if that gets hot. I don't know. Yeah, a little bit. Okay, it's showing 0 volts. Let's zoom in a little bit. There, that should be a decent setup, right? Okay, let's turn on the power brick. Oh, wow. We are getting 24 volts out. Interesting. So, I mean, there has to be a boost converter in there, doesn't there? We'll see. Okay, well let's see if we can do 1 amp. No. Let's see if we can do half an amp. Go. Okay, I don't know where I'm pointing at. So there's the buttons. This is the charger. And this is the little brick. Huh. Yeah, see, I've never had an issue with that, Felix. So it is, but it connects to Wi-Fi, and I can ping it. I can ping this guy on my Wi-Fi network, but then the app can't connect whatever I do. So I don't think it's the Wi-Fi issue itself. But if it's in AP mode, it does work. I don't know. Yeah. So far, it doesn't seem to be getting warm. This is my fingers. I mean, you can see my finger, my fingerprint on there. Okay, yeah, this is the tester. I also have one that is bridged in the same VLAN. It also doesn't work. Okay, let's go to 1 amp. Okay, so we're getting 24 watts. That's about 1 amp. That's right. Oh, yes, we're seeing something. Maybe we saw something. I don't know. A little bit, I think. That's actually not too bad. Oh, I didn't put a meter in there. Hold on. Abort the test. There. I want this guy. There. Okay. Start the test. Well, you guys can't see, but I can. It is drawing... So we're doing 1 amp out at 24 volt, and it's drawing 20 volt 1.2 amps. That's not too bad, is it? Yeah, it's drawing 25 watts and we're getting 24 watts. Yeah. Okay, let me try and reorient this a little bit. Something like that. Yeah, now you can see. Yeah, so 24 watts going out. Oh, no, you can't see that. Okay, 24 wattish going out, and 25 going in. That's not bad at all. And there's a little part getting warm there. Let's go to 1.5 amps. Okay, so now we have 38 watts going in, and we have about 36 going out. That's pretty damn efficient. Can someone calculate that? 38 going in, 36.6 coming out. I think it's a PD trigger with a boost converter, yeah. But it's a pretty... It's doing better than I expected. 1.4 watt loss. Yeah, that's not a lot. Stream, where Quindor just wastes expensive European electricity. 96.57%. That is, for a converter, that's quite good. Okay, I don't know. Let's go to 2 amps. That does it. 48 watts out, 2 amps. 50 watts going in. Okay, 50.9. Let's say 51 going in and 48.7 going out. Temperatures are very reasonable. $95.4. Yeah, that is amazing. I mean, anything above 90% is pretty good for a boost converter for sure. It is getting a bit warmer now, though. So the thermal overlay like this on the camera is pretty good, huh? Let me try and turn on super resolution. Oh, it's already on. Okay. Oh, whatever. Oh, my screen turned off. Why? How do I turn it on? Oh, there's buttons. Okay. Yeah, that is a bit strange there, Philip. Okay, let's go to 2.5. Okay, so now we have 64 watts going in and 60.6 going out. Damn. Let's see on this side. It's getting toastier. This is a Guide ER, Guide IR E2 Plus. I've had it for about a year. I bought it right when it was released because it has the network functionality. It just doesn't work. But in AP mode, it does work, so we're using it like that for now. $2.5 amps over what gauge of wire? That is true. This wire is very thin. Let's see how warm the wires are. Well, it's not too bad. Wait, what? Oh, the software disconnected. What do you mean? I'm still doing the thing. Did it turn off AP mode? No. It just disconnected? Okay. It is connected here. Disconnect, not connected. Okay, yeah, that makes sense. Thanks, Damien. Yeah, I had a pretty good time. Okay, we're back with the thermal camera. Let's see what we're doing here. This plug is 34.8. You can't act. So my screen is different. I have a pointed readout over here and then the overlays. I'm not sure how to do that on the PC though. But yeah. Yeah, the case is about 47 now. Oh, we're cooking here. So if this gets around 60, probably inside it's going to be even warmer. I'd say that is pretty much the maximum. stupid display turned off again? Okay. What? So, yeah, okay, let's go to 3 amps. We're doing 77 watts in and 72 watts out. So the rest has to be in the cable or in the converter. You can check in the video description, there's a link. It doesn't really say what it's rated for. Okay, well this is taking too long. We're going to 3.5 amps. Why did it turn off again? Stupid. Oh, wait. Oh, uh-oh. I know why it's turned off. So it doesn't like doing 3.5 amps, huh? Let's try it again. No, okay. It turns off the USB-C thingy. Let's try 3 amps. Nope. Doesn't like it either. 2.5 amps. Okay, it'll do 2.5 amps. But after that, it'll shut down. So it's likely not a thermal shutdown. So let's nudge it up. 2.9. No, okay. So once I hit 3 amps, it just turns off. .9. Let's keep it at 2.9. Oh, hold on. Yeah, about 70 watts. Wait! No! Stop! Hold the presses. This brick doesn't do more than 3.5 amps. Okay, we need to get a new brick. Hold on. I'll be right back. One moment. The USB-C charger is the limiting factor here. Hold on. Because if we can make it blow up, we are going to blow it up. Let's get out the behemoth. There. This one will not give up. How to best get this on the screen? $1,000,000 watt brick, yes. Okay, we don't need this. So, something. Let's try and get that a bit on screen. Something like that. Okay. Yeah, this is the Hagibis GAN Plus 240 watt power brick. Okay, it's doing 20 watts, or 20 amps. 20 volts. Jesus. Okay, let's go. 2.9 amps. Okay, let's get this somewhat there situated. Okay, 3 amps. Ah, no problem. So we're doing 78 watts out or in and 72 point something out. Okay. Yeah, I'm not sure how that makes sense. I think the wattage calculation is better than the amps. But let's go to 3.5. No problem. It's gonna burn. Yeah, I can feel it being warm now. So we're getting 84 watts with 90 watts in. That's pretty good. It depends on what port, Alexander. So if it's lying on the desk, that's probably going to be the warmest. Oh no, it's not. Okay. Yeah. Still doing it. Okay, let's go to 4 amps. Ooh, yeah, baby. I don't know if this brick is going to deliver more, though. We'll have to see. I have a 140 watt power supply over there. Oh, voltage went down. That's right, Philip. Okay, so... Uh-oh. So I think it's overheating. Because we're not getting 24 volts anymore. Okay, now we're getting 24 volts. Let's give it a little bit. Could be PTC, I guess, yeah. Okay, so let's go to 3. Yeah. I think it's overheating. Let's see how far we can go. Oh, the what? Where? Oh, okay. That over. No. Okay, I think it overloaded the power brick. Because I believe those are 100 volt outputs. Or 100 volt, 100 watts. No. Okay. There. Okay, we got it back. Yeah, I have a 140 watt port there, but then I can't put it on the screen. But even at 3.5 amps, this is only at 90 watts. You can see the voltage starting to drop. Right? So this is continuously dropping now. Yeah, it's not happy. Okay, yeah, I think it's time to open it up. So let's... Oh, I can smell it a little bit too. So, oh, it's nice and hot. Oh, ow, okay, yes, ow. So, let's just hammer something in there. Now that it's nice and hot, maybe we can just pry it open like that. Hold on, I'll try and do it on screen. Ah. In one go. Look at that. Okay. Nice little housing. I'm smelling it a little bit. So, let's see. Oh, wow, the wires are very soft. Okay. Yeah. Let's see what's in here. Do we have a chip? No, there's nothing. Okay, there's a type number there, the GG1722 version 2.3. Nice use of planes, that's good. And then let's see what we have here. Can I read what's on that chip? Not with these. And then I need some of this. Oh, it's an XL Semi XL6019E1. So let me try and show you on the screen. There, XL Semi, it's hot. 6019E1. Okay, and then we have some capacitors. A very large, ow, it's hot. Very large diode. Yeah, okay, let's look that up real quick. An XL6019. Yeah, boost converter. Oh, wait. Why are you not working? Oh, I think LCSC will have it. Yeah, it's a 50-cent boost converter, 180 kilohertz. Oh, it's a 5... apologies. Let's see. It's a 5 volt to 40 volt boost converter, which can do 60 volts in, up to 5 amps out. 94% efficiency. That is pretty good. Yeah, and it seemed to exceed that. Interesting. Okay. Yeah, well, I mean, it's a decent little device. You can look up the datasheet yourself if you want to learn about it more. Of course, with the amount of current we were running at, these capacitors, they're rated for 105, I think. Let's see. 220, and this is 220. Okay, yeah. Yeah, I think these are 105C rated, so you can see it over here. 105C. Well, this one's the same, so 105, yeah. So, I mean, you'll be cooking those in that housing. How do they trigger the 12 volt? Or the 20 volt? So, there's a CC over here. Is this little IC doing the PD triggering? I guess it must. Yeah. So let's see what it says on there. That is a 13A9? Yeah, 389. That's hard to see. Hold on. There. A 138A9. Can I show you like that? I don't think so. No. 138A9. Okay. Let's see if LCSC knows what that is. No, Google. 138A9. PDIC. No. Okay. Okay, well, interesting. It has a very tiny little PD chip. And then a large boost converter with a large coil. But from the temperatures I was just feeling, and we measured with the thermal camera, I wouldn't use this above 1 to 1.5 amps maybe. For that, it probably is fine. But more than that, it'll likely overheat, or at least die pretty quickly because of the caps dying, basically. Still, that is not a bad result. That is partially why I haven't made any PD devices because I really like to have 24 volt, because 24 volt is a lot more useful than 20 volt, which is what you can get out of PD. And yes, there are newest standards, and yes, blah blah blah, but that's all a lot harder. So if you want 24 volt for LED strips, analog or digital, you know, PD would have been really nice. But as it stands, you need a boost converter like this. So you already need to include, like, I don't know, let's say $2 of components, $2.50 of components. Especially if you do it in larger volume, it doesn't have to be too expensive. But then, how are you going to deal with the heat, right? If you want to make this in a nice PD device like a Dig2Go, and then even with that, you're going to get 2 amps out of that. So 48 watts, maybe. That's not a lot. Right? And then you still need an expensive power supply like that, where a real 24 volt power supply is much cheaper. So, I don't know. Boost converting your USB-C output, I'm not a big fan. I also do not know why they selected 20 volt instead of 24 volt, Philip. If USB PD would do 24 volt, that would have been so much nicer. I would have made many controllers for that, digital and analog. But as it stands with 5 and 12 volt, kind of You just leave it outside to keep it cool, yeah? Yeah. Found that exact model on Amazon for $8.99. Oh, it's available on Aliexpress for like $3 or $4. Yeah, okay. Next up is power supplies. Some 5-volt power supplies. Is that guide camera made by them? Well, I mean, it says it on there, right? Okay, we have 2 power supplies. I already showed these off in Quinboxed. The top power supply is the top contender. This is a CE rated power supply with active PFC. It says it can do 100 to 240 volt audio sensing, probably because of the active PFC, and then it can do 48 volts for 110 volt, or amps, not volts, amps, or 60 amps with 240 volt, which is what we have. And this one is about $25-ish or so. You can look up the links in the description. So this is what I'm most interested in. This also looks to have a very heavy-duty, nice design. It really looks like a Meanwell UHP. It has some beefy output terminals over here. And although I find this a bit cramped, it should fit fork terminals really well. And then it has shielded inputs over here for the AC. So that's also pretty good. And all in all, I expect great things from this one. And then, you don't like the terminal style on the output side. It's okay, I think. With fork terminals, this is fine, I think. And then we have the other contender. It is from the same company, or at least they have the same logo. This one is made in China, not CE tested, doesn't have active PFC, doesn't do any of those things. This one is only for 200 to 240 volt, but I believe you can select 110 volt in the listing too. And, well, this one is supposedly doing 40 amps output, but it's only $12 or something like that. But it has more weird stuff. We have our output terminals, which has V minus 3 times and V plus 3 times. That's great. That's great. But then what's going on here? We have our AC. We have a single earth. We have 2 lives and 2 neutrals. What? Oh, maybe it's so you can daisy chain them. But then why don't we have 2 earths? I've never seen that before. I don't know. I'm a bit confused by this. So, yeah. Which one should we test first? They're both for video screens, that is correct. But that should also mean they should do fine for our 5-volt LED projects. Which one do we want to test first? The cheap one or the expensive one? High availability, yes, just hook it up to 2 phases. I'm not going to do that in this video. Wait, where are my testers? Oh, over here. Okay, so this one, yeah. Okay. The cheap one. Okay. Let me connect one of our new wires. Because for 40 amp, I think I need 2 wires. Or 2 testers. Yeah. We'll just click the breaker, nothing fancier. Yeah, maybe. Oh, I split the terminals. Okay, anyway. This should now be in here pretty good. Yeah, nice. I like our new connections. Okay. Let's see. Tester 1. Okay, let's open these up. Okay. We might actually need 3 testers, but I don't know. We'll see. Maybe do a live stream of PNG. Yeah, maybe. They certainly have bigger stuff we could blow up. That is for sure. Oh. Wait, no. Do it the proper way. These larger silicone wires, don't tear them apart, because they will rip. Where's my scissors? Okay, well, we'll take these scissors. I always cut them, so I know they split evenly. See, it was already starting to rip, but now it's a clean break. Good. You have a ring in what? You have AC rings? Okay, let's see if we can do if... Okay, now... Let's do it properly. Let's hook up 3 testers. Oh, wait. This one has 1 finger less. It'll work. So this side is at least good. We can hook up lots of wires. Let's do the AC side. Do I have some AC wiring here? Maybe over here. Come on. Let's see here. I'm guessing this is Earth. I guess in the UK you can do that because all your plugs are individually fused. So live I'm thinking is brown. I'm just going to take one of the lives. I don't know. And then we have neutral. Okay. Yes, good. We need some more test power. Okay. Yeah, we want to keep this on screen a little bit. That's not going to work. Sure. Let's put the glasses on if I can still find them. Uh-oh. Check continuity between V- and V+. What are you talking about? That's cheating. We just need to turn it on. Oh, okay. I'll reset it, sure. That's not how we test things. Okay, let's turn on the thermal camera. Oh, wait. Okay, so this needs to move a little bit like that. That's over here. Sure. Okay, I need to do this stupid AP thing again. Hold on. Okay, fine. Okay. Yes. Okay. Oh, this tester is still a little bit warm. No, we lost connection. What do you mean? Okay, disconnect. Connect. It has the Wi-Fi for like 60 centimeters, so that's very hard. Yeah, these testers, I have like 5 of them. They're awesome. Okay, we're back. I think. Yeah, okay. Yes, okay. So, let's turn on... Hold on. Let's turn on power. See if it explodes. Okay. We're seeing 5 volt on each of them. That's good. What do you want from Wi-Fi for 60 centimeters? Okay, so it's supposedly 40 amps, right? So let's go to 30 amps. So let's go 10 amps. Okay. We're drawing 57 watts from the wall. Okay, let's go to 20 amps. We're drawing 111 watts from the wall. And let's go to 30 amps. And we're drawing 167 watts from the wall. Okay. Oh, I need to be a bit further away to measure this thing. Let's see here. The outputs are over here. This one's getting warm. Why is this one getting warm? Okay. Oh, when I put the switch on, my camera went blank? Maybe it interfered with something. I don't know. Yeah, I don't understand either, but it's definitely warmer than the rest. It's only 20 or 32 degrees. But, I mean, we have 3 testers doing 10 amps each. So, what? What do you... Oh, wait, maybe... Oh, it's this one? Oh, I know why. This wire might be higher resistance. I don't know. No, it wouldn't be warm on that side. It would be warm over here. I don't know. Is the wire warmer? No. Not really. But it's that pair, this pair over here, which is warmer than the rest. Yeah, it's all the same wire. So, yep. This one's even shorter, so... That has the forks, yes. But then you'd imagine this side being warmer, not this side. Let's look at the power supply. Could be a bad crimp, maybe. I don't know. I've used those for a while. Oh, we have something that is 90 degrees over here. What is that? Oh, it's a blue thingy, so that's probably a NTC thermistor thingy. What do you call that? Let's see if I can get it on the camera. Maybe if I turn it around. Yeah, I believe that's a AC thermistor. Or what do you call that? NTC. So that is likely okay that it's that warm. Yeah, I know. These are simple tests, Dutch Taurus. If you really want to measure it, you should measure for more. Yeah, let's go to more amps. So, well, so let's add 5 here. And 5 over here. So now we're doing 40 amps. Voltage seems pretty stable. We're drawing 225 watts from the wall. Yeah, so it's warmer than the other cables, but it's only 36 degrees, 37. Still, it might be worth to remake that cable too. Yeah, it's pretty good. So we have some stuff that's 56 over here, 58. On the AC side, things are a bit warmer though. But it's just that one component, and I believe it's designed for that. So that's not a problem. You're disappointed, it works fine. Yeah. We might have an LED strip later tonight, Leon. I mean, over there's fine. Something is like 60 degrees over here, but, I mean, outside shell is fine. Yeah. It's 40 degrees now. Okay, well, this cable's... I guess. I don't know. Not really. Okay, let's add 5 more. There. We are now at 45 amps. We're drawing 254 watts from the wall. Let's see how our hot component is doing. Seems about the same. Hey, you know me. Some heat is gathering over here, but it's not too bad. I mean, the components inside they're getting warm, but let's go 2 more over here, 2 more over here, and 2 more over here. We're now drawing 291 watts from the wall. Yeah. For a Chinese power supply, this is doing pretty well. Okay, I want to see the bottom side. Well, that's metal, so I can't measure it, but I can measure the table. But it's not extremely hot or something. It's rated for 40 amps, yes. Yeah, so the voltage going down is because of the voltage drop on the cables. Not so much on the power supply, I imagine. Let's leave it running like this for a little bit. This one, I think. No. One moment, please. Oh, I don't know if I can have those open at the same time. Oh man, it's not working again. Okay, hold on. I need to look up the IP address, I think. 103. Yeah, that's what I have. One moment. Why can't I connect? Okay, disconnect. Connect. Yes. My multimeter software isn't wanting to work with me. Disconnect. Connect. Why is all this stuff so useless? Okay, close it, open it again, see what happens. No, okay, multimeter software today says, you know what, maybe you just do your own readings. It's connected, but it's, I don't know. This has only worked 100 times and now it doesn't. What do you mean? Okay, measure. Play. Okay, so what? I don't know what I changed. It's working now. Is this still working? Yes. Okay, how warm is it? Oh, something's getting like 100 degrees over here. That's probably 110. That's probably not good. Okay, let's see what the output voltage is. Well, 503. That looks pretty good. There's no update on diff power. That's going to move to next year. I have been working on some of it, but yeah, I want to do it right. So, and there's lots of other stuff going on. So yeah. I am using the PC software right now, but I have to use it in AP mode because it doesn't work in Wi-Fi mode. Can we get the 110 degrees again? Yeah, there it is. Well, maybe. Yeah, do we want to give it more? I don't know how much my testers will do. Let's see, 18 amps, 18 amps, 18 amps. So 36 plus 18, 54? You can check in the video description, Bart. But I believe I can check too. Oh, wait, it stopped. It stopped. It didn't, oh, it's off. Okay, let's go back to 15 amps on each. Oh, it recovered. So there is some kind of protection in there. Or something just overheated, but... So let's check here. I'm wondering if this AC side maybe protected it. Oh, my camera went dead. What do you mean? Yeah, well, hold on. My camera's rebooting. You buy these expensive things and they work like... Yeah, how shall we call it? Connecting, confirming. Exactly, Philip. Okay. Oh, come on. Reconnect. Damn it. Why? Why you do this to me? Oh. Okay, disconnect. Oh, the whole software just crashed. Okay. Yep. Close. Never mind. Let's try it again. No. Oh, I can't move it when it's connecting to Wi-Fi? What do you mean? I need to move this window. Oh my god, okay. Hold on. Oh, so while it's connecting to Wi-Fi or the thingy, I can't move the window. Wow. Okay. Anyway, let's see here. We're back. For better lab equipment. What? Oh, it's so expensive. But anyway. So this is now... Let's see if I up this one to 20 amps. Okay. More. 18. We're doing 305 watts from the wall. Okay. 20. Oh, no. Okay. Instant shutdown. Okay. So while it's shut down, let's see if it cools down or not. Yeah, this part's cooling down, but I'm betting this one doesn't. No, it's also cooling down. Okay. So go to 15. 15. And it boots right back up. Thanks, Philip, for the donation. That's appreciated. Yeah, so we kind of found the limits, but if you don't mind it running a bit toasty, that's pretty good. That's pretty good. I like it. We already left it running for like 15 minutes. Yeah. Doesn't get... Well, okay. It gets hot. It definitely gets hot. Pretty cool. Let me see what the voltage is with no load. $505. That's basically the same we had with load. I can enable some load. 15. Yeah, doesn't budge. Still doesn't budge. Still, okay, a little bit. That's pretty well regulated, I'd say. That's pretty good. Okay. Yeah, I can't say anything about longevity or whatever like that. But other than that, I fully expected this one to fail, if I'm honest. Yeah. And I mean, when do you need 40 to 50 amps continuously, right? If you're doing like 20 continuously with peaks up to 40 or something like that, you know. Let's see. AC is off. AC is off. Yes. I didn't hear any sound whatsoever. Okay, let's leave this cool down here on the ground because it's quite warm. Okay. Then let's quickly take a look at this guy too. So this is already nicer. You have this protective cover here. These are a bit smaller though, not a problem, but live is over there. There, AC connected, nicely shut away. Yeah, meanwhile is the de facto recommendation, for sure. But I saw these, and especially this one, I thought could have, you know, high hopes. Okay, we might need a fourth tester. Let's get a fourth tester. I can take this guy. This has some thinner cable on there. This has 14 gauge on there. Oh wait, this has the wrong... Okay, we can't use that. $8.66. I mean, come on. You can't build a power supply for that, but it seems to do fine. Yeah, this one definitely looks a lot more sophisticated though. Okay, so let's get this guy connected. Okay, so now we're going to have to do something interesting, because we're going to have to double up forks. So we're going to do one like this. Oh wait. Minus and plus. Okay, I need to get it under the ring there. This one also. See, that's what I was afraid of. I'm actually hitting... I'm hitting the capacitor over there. Hold on. I don't know about that. I mean, I know it's shielded. That's not the problem. Because, you know, what you see is basically foil. But I still don't like that. Let me... Oh, wow. This one only has the one fork. This is going to be interesting. Okay. Where did I put my screwdriver? Oh, wait. Okay, I want to tighten this down there. Okay, our double forking there is done. So now we need to do it for this one. But I don't like it touching those capacitors. So we're going to screw it down like this. Okay. Yeah, I really don't... Is that continuous? Let me check. Okay, we have the beepers on. Okay. So... Oh, okay. Yeah, okay, that's the capacitor. That's fine. This is continuous, yes. But then... Okay, positive side, we have no connection with this capacitor. Good. Negative side... Sure, capacitor, good. Okay, no connection whatsoever. This screw here, no connection. The shell, no connection. Okay, these guys. I'm trying to show you. No connection. No connection. No. Does Earth have a connection to the shell? Yes. And to the screw? Yes. Okay. So Earth is connected to the shell and the screws. That's good. But negative and Earth are not... Yeah, okay, yeah. Negative and Earth are not connected. Good. And this is also not connected. Okay, well, okay. I still don't like it. I mean, this is too tight. They should have given me like 1 centimeter more. But it's at least not connected. Okay, we need to do the little trick again. This isn't sketchy at all. Okay. Well, it's tight, so okay. I don't know about how well that is connected, but you know. Oh man. I would not advise this for a permanent setup, or for any real setup in that regard. Oh, okay. I'm just gonna send it. There, I wrecked our new fork. Kinda. But I think it's all there. This is at least a good barrier, so that's good. You came here for the sketchy. Sure, let's reset these. Oh, wait. Are we back? OBS Studio just reconnected. Can you guys let me know if we're back? Okay, stream died for a second, but we're back and reconnected. Okay, we're back. Good. Yeah, OBS said it disconnected and reconnected. The square connectors. What's a square connector? Yeah, okay. So let's start with 10 amps on each. No, that's one. Jesus. Okay. Let's prepare the thermal camera. You mean these? So normal ferrules? But that's not going to work with these terminals. And I do like fork terminals with Barrio style, like the other power supply I had. That was great. These are just too cramped, right? So, yeah. Especially because this is a higher amperage. So I wish we'd have the other terminals in here, actually. Let me turn on AP mode again. Do all this crap again. On each side of the screw? I don't know what you're talking about. Connect. AP mode. I'm not sure what that would help, but okay. No, my testers are fine. I just need to put them staggered. And this one's missing a foot. So that's a problem. But if you 3D print cases, those are available. Wait, failed to connect. What do you mean? It is connected. Connect again. You can do it. You will limit the thermals, so yeah. Yeah, but if we're doing like 60 amps on this one, you kind of need all these wires. So I don't know how you would reduce that. I'd actually want to use even thicker wires. So I don't know what you're suggesting or how that would work. Because you need this. You can't make these wires smaller, right? Okay, let's turn on the... Oh, no. Bad. Yes. Safety. Thanks, Draadstaal. Well, there we go. Okay, there. Okay. Okay, yep. Okay, we're getting 5 voltish. Yeah, but that's adding a lot of connection points, and then you still need the same amount of cable, yada yada. So, I don't know. I don't know what that's going to fix. So, right. So, let's go 10 amps, 20 amps, 30 amps, 40 amps. Oh, you got another black frame? Wow. Okay. We're doing 40 amps, so that's 200 watts at 5 volt. And we're drawing 220 watts. So 20 watt losses. Okay. What's getting warm over here? Oh, it's another one of those blade thingies. But this one's crammed up to the terminal over here. I don't know. That's pretty close to some plastic. My general feeling about this power supply, I thought I was going to like it a lot. I think I do, technically, but it's too cramped. Right? It's just a bit too cramped. Okay. Let's go to 15. 15. 15. 15. I see. I don't think we've had that issue before, have we? So maybe the inrush of this is causing my USB-C power supply for the 2 cameras to flicker somehow. So we're doing 15, 30, 45, 60. Yep, full load. 331 watts from the wall into, what is that? 300 watts? Yeah, 300 watts generated. Okay, so cable-wise and everything's fine. There's something warm over there. I think those are some capacitors. Maybe. But that's okay. So let's see for the rest. Okay. How warm is that thing over here? Oh, okay. It's only 74. 76, 77. Okay. So even though that's near the plastic, if it's not like 100 something degrees, that's okay. Interesting. That's only... I don't know. We haven't had that before. I did firmware update all of them yesterday. All my cameras and my lenses, but I don't know. Anyway, so far this is very unexciting, unexciting. Yes, good English, Andries. Let's check the voltage. Oh wait, that's in continuity mode. Oops. DC voltage. Let's go. 4.9899. Wow, that's close enough. Does it have a pot? Does it have a pot to adjust the voltage? No, don't think so. Well, maybe over there. Can't really see with the glasses. Let me check with the magnifier. No, that's a screw. No, there is a pot in there. A 103 pot. Okay. Yeah, there is a pot in there you can reach with a screwdriver, I think, to change the voltage slightly. Okay, we can try that later. Oh no, John, that's going to be a while. We still need to do more stuff with it. Okay, so the cables are, let's see, how warm are they? Yeah, that's not really... Okay, let me point at them. Cables are around 41 degrees. Something over here is like 50, that's fine. Yeah, nothing very warm here. Okay. Well then, let's see what it can do. 20. So now we're at 65 amps. 70 amps. We're drawing 389 watts from the wall. Let me do a temperature check. Okay, let's go one more. Okay, we're doing 75 amps. It's getting a little bit warmer, but I mean... Okay, last one. So now we're doing... Oh, okay, didn't like that. Nope, nope, it's saying nope. Okay, let's back off. Okay, not enough. It's blinking. Okay, it's back. It's back. Okay. So it can do 20, 40, 55, 70 amps. Okay. That's 10 above what it's rated for. No, I think you're only going to find these in 5 volt because those are generally used for LED panels. Yeah, don't look at these voltages. Those are fine. If I measure on the terminals themselves, we see 4.98 something, so that's basically perfect. It is starting to get nice and warm here. Let me lift this. Oh, yeah, it's warm. Yeah. Okay, there's some heat on the table. Ah, okay. It's getting too warm to hold. Yeah. Yeah, that's true, Emil. Both of these are video wall kind of power supplies. But they're available at very nice prices. And we can check the power factor, because I have a measurement device here. We have a power factor of 0.994. That is excellent. So, they didn't lie. This is actually active PFC. And they probably also honestly have their CE certificate. So I think we're currently running 70 amps. That's like, I don't know, 10 amps above rated load. Yeah, it's not getting too hot. Probably needs a bit of cooling. 116%. Thanks, Ditch Towers. Exactly, Emil, exactly. So, but if you're doing a 5-volt project, you know, it seems like a good quality power supply so far. Can't, again, say anything about longevity. But at least if you're hooking up like a Dig Octa power board, yeah, this will do 50 amps no problem. Yeah, those capacitors are getting nice and toasty, but they're probably 105C rated, so shouldn't be a problem. And I believe these ones, these blue ones, they're polymer ones, so those don't really care about the heat anyway. Yeah, and even that... Oh, shutting down. No. Even that component over here, which is getting very warm, it's not too warm. So, okay. I like that the AC wires are blocked with this cover. That's good. Nice and compact. No problems here. This, it's a bit too tight, and I don't like that you can touch those capacitors with your forks. Then again, when you screw it in and you pay a little bit of attention, that shouldn't happen. So, "36 8x8 RGB pixel boards." Nice. Well, I bought these because I'm going to do a project with 16 of those 16 by 16 matrix thingies. I want to make something new for here on the background. We'll work on that at some point. What about using rings? Yeah, probably works. I think that'll fit. Let me try and get it on the screen. Ow, it's hot. See, the problem is I can just poke the forks in too much and then they touch the capacitors. Well, at 100%, then we need to lower it. Let's see, 15, 15... 15. So, it's doing 331 watts. Sounds cool, Emil. So it's about 90% efficient, I guess. That's not too bad. 90.6, yeah. And I mean, it is warm. I can see how they constructed it, and they're using the walls. So these walls over here have the MOSFETs and stuff like that on there. Like over here, and over here, and over here. So they're using that for cooling. So the bottom side... Yeah, the bottom side... Ow, okay. The bottom side is also pretty hot. So, especially if you wanted it to last, you could screw it down on something metal, and then it'll last even longer. It has these tabs here, so you can screw it down to a metal plate to, you know, put some thermal grease on there, and it'll have even better heat dissipation. Or you can just point a little fan at it, and that'll probably also help it a lot. If you really want to run it at 60 amps continuous, which it seems to be doing just fine. I believe we reset the testers, and we're currently at 147, so we've been going almost 15 minutes full load. That's fine. At least 10 minutes. Yeah. Cool. Okay. So, basically everything we tested today was above expectations. Who would have thought? Oh, idle load is 4.7 watts. Okay. I mean, I really tried there, Alexander. It's not like I don't try. It's just... It just doesn't happen. Yeah, let's disconnect this from AC. Good. Now let me disconnect my ow, hot. Okay. Mangled wires here. They are beefy terminals. I'll give them that. They just needed half a centimeter, 5 millimeters of space. But they are good terminals. Yeah, it is. I just selected one I liked, or I wanted to test because I have a 5-volt project coming up. Yeah. Yeah, the USB thing, I thought it would do 1 amp and then explode, but it seemingly did a lot better. Okay. My child keeps popping in to see if Quinder made fire yet. Aw. Sorry. Not this time. So I don't really have a secret today, but I have something I just got in today, which we can test together. Let's get the testers out of the way. Don't need all of this. Turn all this off. This needs to move. And this, okay. So let's take a dig next to prototype, and if you haven't seen it, maybe this is a secret actually, because I got these back from China. These are the new back plates I made. So they have not all, but most of the GPIO pins on there. And well, this is the dig next to the upcoming controller I still hope to release this year, but we'll see. Let me get a wire for the, oh wait. Okay, let me disconnect these. That's actually a previous version. Okay. These are injection molded. So these are a fully custom injection molded housings for this controller. And if you know a Dig2Go, these are basically of the same quality. So no flimsy plastic or something like that. Really nice, high quality plastics. Flame retardant plastics, actually. Okay. I wanted to test this guy. SK6812 RGBWW, this is so warm white, I guess. 96 LEDs a meter in IP65. What? Oh, you wanted to scan it? Hold on, here. But you'll get to some documentation that's not done yet. It works in real life. I guess we use their wire. So for pigtails, red wire VCC, middle wire data, the other wire. What? The other wire is ground. So this is very different design versus my other controllers. This has upgraded circuits for basically everything. It's listed on here that it's recommended for 15 amps, but it'll do 20 amps easily. I just had to put something on there. But the reason is it has two 5-amp fuses. So two 5-amp fuses and one 10-amp fuse. So basically it can do 20 amps, but yeah. So let's connect this to here. Okay. Yeah, one of the unique things this guy has, if you're seeing the top here, of course it has a fuse per output channel, so each output is individually fused. But then it also has a relay individually per output channel. Now, the software right now can't really make use of that yet, but I do see some things for that in the future which could make that interesting. Yeah, so I really wanted to have this out in August. No, well, okay, don't. These are still prototype PCBs. So the end will have color-coded terminals for all of the terminals, and it'll have Phillips screws. Don't worry about that. We still have more here. We have USB-C. We have the Q expansion port. And we're getting custom-made cables for that. I don't know if I have one here. I think so. Yeah, okay. We have the Q expansion port, which you can plug in like so. And then you have 4 times GPIO plus power and ground. Then we have a 4-pin terminal. I don't think I have a block here. No, okay. We have a 4-pin push-in block terminal for 2 buttons. And then on the side, we have even more. We have a 3-pin cable you also get with it. I don't know where it is right now. Maybe here? No, don't know where it is. But you get the cable with it. And that is for 5-volt trigger and ground for a relay board. So if you wanted to have external relays, even though you already have internal DC cutoffs. Let's see, power. So this is hooked up correctly, I think. Yes. Ow. There. So expected release is somewhere in December. As I said, I really wanted to have it out by August, but that didn't happen. Hey, why is my power supply not turning on? Okay. 12 volts, 10 amps. Yeah, that looks good to me. Okay. Yup. Turn on. Let me check which IP it got. Maybe this didn't have an IP yet. Let me check if broadcasting something. Yes. Okay, let me hook it up to the network real quick. Come on. I need to type it in. It's a buggy version. Hold on. So this is still a prototype board, so these LEDs are too bright and things like that. Let's see here. 10, 24, 1, 1, 2, 3. 10. Okay, let me configure that real quick. Go away. Okay, so we got orange. Let's see, 96 times 5, 480. Oh wow, that's actually the maximum amount you'd probably want to run. Save. Whoa, okay. That's nice and bright. Okay, we shouldn't run it on the spool anyway. Let me check some values here. If I go 100% red, it's drawing 3.28 amps, 40 watts. Blue, same. Green, same. Dual color, double. Interesting. So is this one of the insane ones? I think so. Yeah, okay. If I do white, 100%, it's drawing 7.5 amps. So this is basically the SK6812cc again, I think. But then in a 96 LEDs per meter configuration, which is pretty nice. Yeah, camera is blown out. Hold on. Turn it up a little bit. Rainbow, rainbow. Where's my rainbow? Yeah, that's pretty good. And we're getting 43 FPS, so with 480 of these on, you know, yeah, that's probably the max. So this one will not have Ethernet, because I would have to radically change the design for that. And there's basically no room because of all the other stuff. No, this is just some strip I bought. It's not. I just wanted to test something. Let me look up the listing and then put it in the video description. Oh, they're not letting me affiliate it. Oh. Okay. Edit. How do I edit? Edit. 96 LEDs a meter, SK6812. Save. Okay, the strip is in the video description. So this will always come with the external antenna. I'm not really sure yet if it's going to be this antenna. We're still finalizing some of those details. But one of the cool things is if I now turn off the power in WLED, you'll see that the output actually turned off. So right now, even if I measure with my multimeter, let's take a ground terminal here. And if I measure this positive terminal here, there is no voltage on there whatsoever. Right? So these are actually, let's say, physically turned off. These are still draining because there's nothing attached. And then if I hit the power button again, bam, 12 volts, no problem. One of the other unique things is this one will do 5 volt, and that's true 5 volt, up to 48 volt. So this will be the first real 48 volt controller. We already had the Power 5 HV in the Dig Octa system. But yeah, so this one won't have Ethernet. Yeah, it's a downside. There will be another bigger version which will have Ethernet in the future. But I had to make a choice there, and I decided that this one wouldn't get Ethernet for now. Maybe there will be some version in the future. But I'd have to change the mold, so probably not anytime soon. Yeah, but it's all in all a very nice, fairly compact controller with a lot of features. It also comes with a lot more protections on the outputs. So even if you short a data channel to 48 volt, your LEDs will die, but the controller won't. If you want DIN rail, it will not come with this. This is an optional accessory. You can click in the controller, and it has the DIN rail clip over here. And you can click in the controller like that. And sure, this is on the side, but then this protrudes anyway, so you should be able to easily mount or route a cable like that to get it out. But this, you will be able to buy this mount with the DIN rail for like $2.99 as an extra. And you can either use it for the DIN rail like that, or you can unscrew this, and then you can use these eyes either for a Velcro strap or to screw it down. Right? So you can put some screws through here and mount it down. And then you can still unmount the controller, because sometimes you'll want to get in here if you need to replace the fuses. This does come with a broken fuse indicator like that. So if a fuse breaks, you'll at least know. Yeah, I wasn't able to fit that in there. So Alexander, that's why it's on the side. It does have a stemma QT, so for I2C. So there's lots of expandability. And if you have a 3.3 volt relay, you could use one of these pins or one of these pins also. This just has a very nice 5 volt trigger pin. So, there. Interesting, Greg. Yeah, this will certainly do that. This is basically to have an alternative for the Dig Uno and Dig Quad. It has some upgraded features, but it's mostly to get it into a nice case, right? Yeah. And this one, it's not getting too warm. That's interesting. No. This is, it indicates when a fuse is broken, okay? Maybe at some point, Alexander, maybe at some point. I did not live stream building these boards, no. But we did do some testing on earlier versions, I believe. Some other interesting facts. This has 8 megabytes of flash storage, so not 4 megabytes, and 2 megabytes of PS RAM. So it'll, it's a bit more future-proof for when larger versions of WLED or other software are released. Well, it'll be a separate version, probably the DigNext 6 or something like that, which will have more outputs, Ethernet, and some other features. So yeah. Anyway, we were just testing this little strip here. It's an interesting, I like 96 LEDs a meter. That's a good compromise. And it looks to be the SK6812CC. So that also is pretty nice. Yeah, we're working on it, Philip. We're working on it. The 6812cc, basically, I think I already have measurements for that. It uses a lot of power if you basically blast it. Like doing this, well, it's not too bad. 2 amps, 1.6, 1.7. This is on WLED. Which one? This one? This is Aurora. Yeah. Camera's a bit blown out. Anyway, let's physically turn it off. We have an idle usage of 0.7 watts. That's pretty good. So now you don't have to worry anymore about LEDs eating up idle wattage. So, yeah. Anyway, that was a long stream today. Well, not too long. 2.5 hours. Yeah. Oh, that's fine, Greg. Hey, Malaki, you watching again? We tried to blow up stuff today, but it all worked above expectation. So that's good to buy it, but it's less fun to watch, isn't it? Maybe we'll blow up something some other time. Who knows? Umakavala, that is still at the top of my priority list. I did make some progress with that while visiting China. So, yeah, to be continued. Yes. Okay, well, I'm going to call that quits for today. Thank you all for hanging around with me while we test random Chinese power supplies and equipment. He says hi. Okay, nice. Your other son, Lucian, says hi too. Okay, hi guys. I'm going to go. Thank you all for watching, and we'll do something else the next week. Thanks, guys. Bye-bye.